Inequalities, lesson 6-5. Okay, so let's go ahead and get started. What I'm going to do is set up a problem here, and we're going to see if it's a true solution for the inequality. So here's our solution. We have 2, 4, and we need to see if it works for this inequality. Y less than 2x plus 1. The easiest way to solve this is to set it up in a chart. Sorry for the not straight lines there. Okay, so we have y on this side. We're going to set it up exactly how it's written here. And we have 2x plus 1. Now at the end, we need to make sure that whatever answer we get here is truly less than the number we get here. And just a reminder, this is less and this is more. Only if your variable is right here on this side. If your variable is on that side, then this is how you read it. So just to make sure. Now if it has a line underneath it, then it means equal to. Okay, so let's go ahead. What is the y in this form? Well, this is x and this is y. So what's my y? It's 4. So 4 is the answer on this side. Now we need to solve in the x to see if it works out. So what I'm going to do is I'm going to do 2 times, well, what's my x? Right here, it's -2 plus 1. 2 times -2 is going to give me -4 plus 1. -4 plus 1 is going to give me -3. All right, well, now let's see if this was a true solution. 4 is less than -3. Nope, that is incorrect. So this one here is not a solution. And you can just write it just like that. Okay, now let's try another problem here. All right, let's try this one. Here's our solution pair, 3, 1. And here's our equation. Y is greater than x minus 4. Okay, again, let's make our chart, hopefully with a better line than I'm drawing there. Okay, we have y, and then we have x minus 4. Now, what does it need to say? It needs to say that y is greater than. All right, well, what is our y? Our y is 1. So 1 needs to be greater than whatever I get over here. So we get 3 take away 4. Okay, 3 take away 4 is going to give me -1. So our answer on this side is -1. Well, let's read if this is correct. Is 1 greater than -1? Yes. So you would write in your answer column that 3, 1 is a solution. Okay, that one is a true solution. All right, let's look at this problem. We have 4, 5 as our solution pair. We have y is less than x plus 1. And we have the solution pair of 1, 1 with the inequality of y is greater than x minus 7. And what they want us to do here is tell whether the ordered pair is a solution of the inequality. Here we're just going to do 2 at a time. All right, so y needs to be less than what we get on this side. So my y is 5. Okay. It needs to be smaller than what I get over here. Well, I must substitute in 4 for the x plus 1. And I get 5 less than 5. This is not true. 5 is not less than 5. 5 is equal to 5. So this is not a solution. Okay, let's try this one over here. We have y needs to be greater than x minus 7. My y is 1. It needs to be greater than what I get over here. So I'm going to do 1 take away 7. 1 is greater than -6. So yes, we would put 1, 1 is a solution. Okay? All right, let's go ahead and find another couple problems here. Now, when you are shading, you have 2 different types of graphs. You have a graph that has a solid line, and you have a graph that will have a dashed line. All right, the difference between the two is whenever you have a less than or equal to or a greater than or equal to. Notice the line underneath making it equal to will give you a solid line. So when you're graphing, your line will be solid. Okay? Now on this one, this is going to be just your normal less than and your normal greater than. This means when you graph it, your line will be dashed. And of course, you're using a ruler, so it's nice and straight. Okay? Now, if you are graphing an inequality that is positive, then your graph will have the shading above the line. Okay? If your graph is negative, then you will have your inequality below the line. Okay, so now you have your lines. Let's talk about shading. When the inequality is written like this, y greater than or y greater than or equal to, whenever you have this situation, the shading will be above your line. Okay, above your line. If you have a situation where the inequality is written as y is less than or y is less than or equal to, then your shading will be below the line. Okay, so here, let's just go over this again. If you have a greater than or equal to or less than or equal to, your line will be solid. If you do not have an equal to, then your line is dashed when you graph it. Now, if the statement shows that the variable is greater than in any way, then the shading goes above. If the variable is less in any way, then the shading will go below. Okay, so we have a problem where we have y is less than or equal to 2x minus 3. Now the first thing we want to note is that y is already solved for. Okay, step 2, we want to know that the graph of the line will be solid because we have the equal to symbol. The inequality will be shaded below the line because this is less. So we have some tips. We need a solid line and the shading will be below the line. Alright, so let's go ahead. Now if you remember in our previous lessons, to graph an inequality, we look at the slope of the line or in our y-intercept. Okay, so our slope of this one here is going to be 2 over 1, which if you remember means up to over 1. Okay, what's our y-intercept? Well, our y-intercept is going to be 0, negative 3. So let's do that first. We go 0, negative 3, that's right here. We're going to go up 2 and over 1. So here's our line, okay? Now let's look here at our problem. Are we going to draw a solid line or a dashed line? Well, we have an equal to, which means we're going to get a solid line, okay? Now, is it shading going to be above the line or below the line? Well, this is less than. So if it's less, then it needs to go below. All right, so there are our instructions on how to shade. Now let me see if my best ability to draw a straight line here. Best I can. Notice I made it solid because it's an equal to. And let's go ahead and we'll just kind of shade in this whole area here. And that's all you have to do. Okay, so let's try another one. All right, we have the problem that we need to solve first in order to graph. So we have 5x plus 2y is greater than negative 8. Well, let's go ahead and solve this. We want it to be in slope-intercept form, which means we want y by itself. So we're going to first move the 5x. So I'm going to go ahead and subtract 5x from both sides. Okay, these cancel. And I get 2y is greater than negative 5x minus 8. And the reason I put 5x before the 8 is because slope-intercept form, I need the x before the y-intercept. All right, now we need to get this y by itself. It's being multiplied by 2, so we're going to divide by 2. What you do to one, you got to do to them all. So I'm going to divide by 2 to all of these. this cancels, and I get y is greater than negative 5 over 2x, and 2 goes into 8 4 times, so minus 4. Well, what information do I have here? Well, I have the y-intercept here, which is 0, negative 4, and I have the slope, which is negative 5 over 2, which means down 5 to the right 2. And then once I can draw that line, then I can go ahead and shade. So let's go ahead and graph that. So negative 4 here. We're going to go down 5, which you can tell my graph didn't go far enough, but that's okay. So 1, 2, 3, 4, 5 would be about here. We're going to run 2, which is about here. Okay? Now, we do know that we have a dashed line because our original problem was just a greater than symbol. It did not have the equal to. So I'm going to kind of make a dashed line. I should have hit the mark a little bit bigger. Okay, now it also said, just to remind you, the original problem was 5x plus 2y greater than negative 8. Okay, greater than. So that means the shading is going to go above, just like so. All right, well, I hope this helps a little bit.